Okay, this is Business 342, Workbook Lecture, page 77, Measuring Systematic Risk. There is a reward for bearing systematic risk. This is not a reward for bearing risk unnecessarily. Therefore, the expected return on a risky asset depends on that asset's systematic risk, since unsystematic risk can be diversified away. So what they're saying basically is you'll get rewarded for the systematic risk because everybody has to take that into account. You can't diversify that away, but you're not going to get rewarded for having a portfolio that isn't diversified, where you haven't reduced the risk to where it should be. For unsystematic risk should be zero. It doesn't matter how much total risk an asset has. Its expected return depends only on its systematic risk. We use the beta coefficient to measure systematic risk. A beta of 1 implies the asset has the same systematic risk as the overall market. Okay, less than 1 means it's got less risk than the overall market. So if it's got 0.5 beta, that means it's got half the risk. Over 1 implies it has more systematic risk than the overall market. So if you have a 2 beta, you got twice as much as the overall market. Okay, some examples. Okay, like Microsoft, it's a big company. Even though it's a high tech, it's kind of fairly straightforward as far as it's got a product that it sells consistently. It's got a little bit higher risk than the market. Bank of America, since it's in the banking business and the economy goes down and it slows down banks a lot, that has a higher risk than the overall market by quite a bit. Ford has quite a bit of risk, systematic risk. You can see Exxon doesn't. It's a big company. People have to buy oil, but it does slow down. But it doesn't have. This is the overall market compared to. So that's all the companies together combined have a 1 beta. So it has less risk than the overall market. And Kellogg, since it sells food, has much less risk than the overall market. Okay. But this is systematic risk only. Remember, beta is just systematic risk. Okay. Standard deviation, on the other hand, is overall risk, systematic and unsystematic. Consider the following. Standard deviation for security C is 20%, and for K it's 30%. Beta is 1.25, and for K it's 0.95. So who has the highest overall risk? Security K does. Okay, but that's systematic and unsystematic, whereas security C has a 20%. Who has a higher systematic risk? Well, security C does compared to security B. Okay? Security K, excuse me. So which security has more risk? Well, K does, because standard deviation is a measure of overall risk. Which security has more systematic risk? Well, security C does, because beta is a measure of systematic risk. Which security should have a higher expected return? Okay? Remember, expected return correlates to beta, their systematic risk. They don't reward you for having high or any unsystematic risk. Obviously, in this case, they have quite a bit of unsystematic risk because with its beta being lower than security C, it should have a lower standard deviation if it was just systematic risk involved. If it's got quite a bit of unsystematic risk, that's why this overall risk number gets up higher. You only get rewarded for your systematic risk, which is your beta. So this should have a higher return because it's got higher systematic risk. Okay? Okay, this is page 78. And so it continues. Portfolio betas, and beta is just the sum of a weighted average. Okay, So this is weighted just like, I call it a weighted average. You sum the weighted averages or whatever you want to call it. Okay, so the beta of a portfolio equals the weight of the first security times the beta for that security plus the weight of the, for the second security times the beta for the second security, and so on. So all you do is multiply the weights times the betas. They don't have the weights right here, but these add up to 12,000, so this would be 0.5 is the weight. This would be 4 over 12,000, 0.333, and this would be 0.167. That's the weight for each one of these. So it's just the beta times the weight, and then you add them together. Okay. Beta and risk premium. Remember that the risk premium is the expected return on a risky asset minus the risk-free rate. Okay, the risk-free rate is on a risk-free asset. That's the risk premium. The expected return on a risky asset minus what you'd get just on a risk-free rate. That's the risk premium. The higher the beta, the greater the risk premium should be. In fact, we define the relationship between the risk premium and beta so that we can estimate the expected return. Now they talk about the capital asset pricing model, the CAPM. That defines the relationship between risk and return. And we'll go over that. And then the security market line, which is just a slope, and it represents the overall market rate of return. So the security market line is the expected rate of return of an asset equals the risk-free rate plus the expected return on the market. That's what M stands for. RF is risk-free rate, the rate of return on a risk-free instrument, times the expected plus the expected return of the market minus the risk-free rate times the beta of that security. So the expected return of a security equals the risk-free rate plus the expected rate of the market minus the risk-free rate, which again, remember, this is expected return, these two things. Excuse me, this is risk premium, these two things, times the beta. So basically, the expected return on an instrument should be whatever the risk-free rate is plus the risk premium for the market times the beta for that instrument. Okay, so R is the risk-free rate, RF is the risk-free rate, the expected return on the market minus the risk-free rate is the market risk premium. That's the market. Remember, that's for the market. Before they're talking about just a risk premium for an asset, is just the expected return on a risky asset minus the risk-free rate. That's for an individual asset. That's the risk premium for that. This is the market risk premium, which is the expected return for the market minus the risk-free rate. Okay, beta is the measure of the systematic risk. We talked about that. So the security's risk premium is the expected market risk premium. This is for an individual security. Okay, that's this part of it right here. For an individual security, you take the market risk premium times the beta for that security, and you add to it the risk-free rate. And that makes sense because you take the risk-free rate plus whatever the market rate is, the market premium, excuse me, is, times the beta for that stock. Because remember, beta tells you how much systematic risk that security has compared to the overall market. So if this is the overall market risk premium, and you multiply it times its relative risk, which beta is the relative risk for a security compared to the overall market. Remember, 1 is the beta for the market. So if you just have the market risk premium and it's 1, it's to be the market risk premium times 1 equals the market risk premium, right? But when you've got times the beta for individual security, it's the market risk premium times that beta, which is relative risk compared to the overall market. You add to that the risk-free rate, and that gets you the expected return for that individual security. Okay, so that's the capital asset pricing module, which the SML, the security market line, represents. Okay, so consider the betas for each one of these assets given earlier and the expected return. Now you note the risk-free rates. Okay, consider the beta for each of the assets given earlier. If the risk-free rate is 0.8% and the expected market return is 0.68, what is the expected return for each? So you can see that what they did was the beta for each one of these would be the B1 over here, and then the expected return would be obviously the expected return for the asset, and that would be plus that risk-free rate, which is 0.8. 0.8 would go here, and the 0.8 would go there, and the expected market return is 6.8, so you'd plug that in here. So for instance, let's just do one of these real quick. It would be ERI equals the risk-free rate, which is 0.8, plus the market risk premium, which is the expected market, plus the expected market return, 6.8, minus 0.8, the risk-free rate, and then times the beta, 1.14. And if you go through and calculate that, this is 6 times 1.14, so 6 times 1.14 equals 6.84 plus 0.8, 7.64. So if you go through and calculate this whole thing, what I just did, 6.8 minus 8 is 6 times 1.14. So you do that first, add that to it, and that gets you the 7.64. So that's how those all figure in to give you your expected return based on that formula. Okay, so that's page 77 and 78 on the workbook lecture for Business Finance 342.